All right, do we have any questions on the homework? I'm sure we do. No questions?
99.
29. This is 6.4. Solve each equation. E to the 3x is equal to 10. So it's an exponential form, so you change it to logarithmic form. So this is the same thing as log base. What base do I put here? E of 10 equals 3x, right? Because this is the same thing as e to the 3x equals 10, right? But we don't write log base e of 10, right? What do we write? Natural log 10. Anytime the base is e, we call that natural log. And that's equal to 3x. And then how do you solve for x? Just divide both sides by 3. So you get natural log 10 divided by 3. That's all you gotta do. And that you can punch in on your calculator, right? To get a number. You guys know how to punch this in on your calculator? Because I think the next quiz you're gonna have to do that. Yeah. Yeah. So whatever calculator you have, whether it's graphing calculator or just scientific calculator, you gotta be able to use, there's two buttons, right? You got this button, right? And you got this button. This one is, what base is this? You don't write anything?
10.
Yeah, this is base 10, this is base E. These are the only two you have on your calculator, you know. But you guys should get into the habit of using this one because when you get, by the time you get to pre-cal and calculus, everything will be natural log. Okay, any other questions? Yeah, so all you gotta be able to do is change it from one form to the other. That's gonna be on the next quiz. Next quiz is next Thursday. Yeah, that's the. Oh, but next Thursday. Oh, but at least it's not on Friday, right? Because Friday's homecoming, right? Oh, look at that. Next week got PSAT, holiday on Monday. Man, it's like a jolly holiday for the last couple weeks already. All right, no other questions? All right, then we're going on to 6.5, properties of logarithms. Now, tonight's homework, like I said, not that difficult, but then it's gonna get tougher as we go along. Let's review some things that we learned already. Let's see if you guys even remember this. What is the relationship between these two graphs? Y equal b to the x and y equal log base b of x. What is the relationship between these two graphs? They're inverses of each other, okay? And then from now on, I'm gonna make it simpler for you on the graphing, okay? From now on, so when you take the test, when you graph an exponential function, you just have to plot the point 0, 1. You don't have to even plot those other points. And if this number is bigger than 1, you just go like this. That's all you gotta do. You don't have to plot those two other points. Okay? And then, how do you graph this? Well, it's the inverse of that. So what's the inverse of this graph? Well, if it passes through the point 0, 1, if you switch the x's and y's, you get 1, 0, and then you just do this. See how they're symmetric about the line y equal x? And since these are inverses of each other, what happens when you take one and plug it into the other?
Equals x.
You get x. In fact, I was just looking in your book, they have a list of all of these things all in one place, you know. So if I take this and plug it in here, you get what? B, I wrote this on the board before, I don't know if you guys even remember. What is that equal to? That's equal to x. That's because they're inverses of each other. If you take one and plug it into the other, you always get x. And then the other way too, if I take this one and plug it in here, you will get x. So log base b of b to the x is equal to x. Okay, I'm gonna box that because you're gonna need to know that at tonight's homework. So let's look at some examples. What if you had 5 to the log base 5 of 7? Without doing any work, what does that equal to? Yeah, but 7! That's this one right here. Yeah, but it only works if that base and that base are the same now. Okay, what about this? 10 to the log 3. What is that equal to? B. How come, Mr. Park? That's because when you have a log and there's no base written, doesn't that mean it's base 10 over there? That's why it's 3. B to the log base B of x is x. Okay, what is e to the natural log 4? 4. How come, Mr. Park? That's because when you have a natural log, what is the base that we don't write? It's e. So when this base and that base are the same, the answer is just that, because they're inverses of each other. So you're going to have several of those tonight. And then the same thing over here too. What if you had this? Log base 6 of 6 to the 5th power. The answer is just 5. That's using this one right here. And again, because they're inverses of each other. Okay, so we already learned that before, but you just never got any problems on it. Tonight you're going to get problems. Now here are your properties of logarithms right here. I'll write them on the board, but it's in your book. Properties of logarithms. I'm going to spend several days on this. Okay, so here's the first one. Log base b can be any base of m times n is equal to log base b of m plus log base b of n. So if you have a logarithm and two things are multiplied, you can just split it up into two things like that and make a sum out of it. Log base b of m divided by n is equal to log base b of m minus log base b of n. Okay, so when you multiply it, then it comes out as a sum. If it's divided, if the argument is a quotient of two things, then you subtract. Log base b of m raised to the nth power. Well, you can, when you have something like this, you can take the power and put it in the front like this. N log base b of n. Yeah, they look kind of strange right now, but you do it for a few days. And of course, you go to pre-calculus and calculus, we use this like without even thinking already. And then the change of base formula. So these are what we call the properties of logarithms. These are the three basic properties. But then we also have the change of base formula. And you want it, lots of times you need this because on your calculator, you only have base e and base 10 logarithms on your calculator. Like what if you have a different base? You have to be able to change it. So this is it right here. Log base b of a is equal to, so let's say you have a logarithm and you just don't like that base. You can change it to another base by doing this. Log base c of a over log base c of b. This is the change of base formula. And this one's easy to remember because you can make any base you want, it doesn't matter what it is, but look, the top number goes on the top and the bottom number goes on the bottom. So it's easy to remember. Okay, now, tonight's homework is you have to use these. Okay? In fact, you know what? Why don't I just do examples from the book again? I'll do the even ones and you do the odd ones. So here we go. So what kind of problems are we doing tonight? What does it say? From 7 to 35. Okay, let me do number 8 for you then. Number 8. Log base 2. So this is the thing we just talked about. Of 2 to the negative 13. We just did this 5 minutes ago. You look at that and the answer is negative 13. Remember? Because they're inverses of each other. Okay. That one you're not really using anything. Okay, here's number 12. E to the natural log 8. I gave you an example almost exactly like that. 8. And again, that's because if you have a natural log, that means the base is e, right? And when these two are the same, the answer is just 8. Easy. Okay, but here we go. Here's number 14. Log base 6 of 9 plus log base 6 of 4. Now notice that you're adding two logarithms together, like over here. That means you're going to use this property here, the first one. Okay? So what is this equal to? If I apply that first property to this is the same thing as log base 6 of 36, right? Because you, see, when you add two logarithms together, you can just make a single logarithm, but look, what happens? These two things have to get multiplied together. So when you have 9 and 4, then that's going to become 36. And that's enough. This is like today's quiz right there. I think we can do this in your head. What does this mean? This means 6 to the what power equals 36? 2. There you go. So on the next quiz, that's exactly the kind of problem we put on the quiz there. You have to be able to use those properties. Okay, and then let's do something where you got to divide. Let's do number 16 then. Log base 8 of 16 minus log base 8 of 2. Now notice that these two logarithms are subtracted, like over here. See that? So I want to use the second property. So when you subtract logarithms, you can combine them into a single logarithm, but what do you have to do with these two arguments? You divide them. What is 16 divided by 2? Here, you know what? I'll write it down like this so you can see what I'm doing. And then that becomes 8. And then is this a number I'm supposed to know? What does this mean? This means 8 to the what power equals 8? 1. See, because the way it was written at first, you couldn't do anything with that, but once you combine it into just one logarithm, then easy. Okay, and then is there one with an exponent? No, I'm going to do number 18. What the heck, I might as well just do all the even ones. Okay, now, I see two logarithms, and they have the same, and they have different bases. See, like, when they have the same base, then you can use all of these properties, but over here, they don't have the same base, Mr. Park, what do? You use the change of base formula. So, there's 3 things you can do. You can change both of them to base 3, since that's 3 and that's 8. You can change this one to base 3. Or you can change this one to base 8. So they're all base 8. Or you can just change both of them to some different logarithm. Base, it doesn't matter, that's why. So what do you guys want to do? 3, 8, or something different like base E or base 10. You should get into the habit of doing base E or base 10 because those are the ones on your calculator. So pick one.
10.
Wrong.
Oh.
I told you guys when you get to calculus, everything is on natural log. So I'm just going to train you now. If you have to change the base, just change it to natural log. So watch this. Using the change of base formula, this is the same thing as natural log 8 over natural log 3. See how the top number goes on the top and the bottom number goes on the bottom? Okay, what about this one? Change this to natural log. Natural log 9 over natural log 8. See, it's easy to remember. Top number goes on the top, bottom number goes on the bottom. These cancel out, right? Because natural log 8 is just a number. It's like 2 point something. So you can cancel that out. Now what about this, Mr. Park? This is what I'm left with. Natural log 9 over natural log 3. How do I simplify that? Can I just cancel out ln and ln? No. Because these are attached. This is like a whole quantity right here. It's not like natural log times 9. It's natural log of 9. They go together. So, what do I do?
Reduce it.
Huh?
Reduce it.
How?
3.
No, you cannot. You cannot. You have to use your properties of logarithms. So here, let me show you what you need to do. You have to change 9 to 3 to the second power. What? Why?
Oh, common base.
Because look at this third property. That's the one we didn't use yet. When you have a number to a power, you can put this power in the front. So, natural log of 3 squared, what can I do with that power? Put it in the front. Like that. Now you can cancel natural log 3 with natural log 3 because they're both the same number. It's like 1 point something. And so what's left? 2. You cannot cancel like within, like you cannot go 3 goes into 9 3 times because these two, that's like a whole quantity there. This is a number, this is a number. Okay, we just got to keep on looking at examples till we get it. Okay, number 20. I guess you just gotta use this side of the board since we're filming. Hey, this just looks just like the quiz that you're gonna get next week. And like I said, it looks kind of difficult now, but you do it a few times, it's not that hard. Okay, now just look at the power. I have two logarithms added together. Oh, so I'm going to use this one. I'm going to use the first property right there. So, how can I combine these two logarithms into just one logarithm? Log base 5 of, when they're added together, what do you do with the arguments? Look, when you add two logarithms, if you just make one, what do I do with the two arguments? Look, you multiply them together. So what is 6 times 7? 42. And then doesn't this problem look easy now? We just did this 5 minutes ago. So what is 5 to the log base 5 gorilla? Gorilla! How come? Because they're inverses of each other. When this base and that base are the same, that's the answer right there. Okay, and shall we even attempt to do another one? Okay, let's go to the next section. Okay, it says, in problems 23 to 30, suppose that natural log 2 is A. I don't know why they just don't give you the number. Natural log is 0.693. Okay, but that's okay. You get, it's the same thing. Natural log 2 is equal to A. Natural log 3 is B. Use your properties of logarithms to write each logarithm in terms of A and B. So let's do like 24 then. That's an easy one. Natural log of 2/3. Now, of course, if you have a calculator, you can just punch it in like that. But they want you to use these here. So, I have natural log of something divided by something. Which property am I going to look at now? Where? Yeah, right here, this one. See, natural log of something over something. It just means the base is E, right? So, according to that second property, what is this equal to? Natural log 2 minus natural log 3. Well, what is natural log 2? It's A. And what is natural log B? Oh, I forgot to put the equal sign there. What is natural log 3? It's B. So that's it. The answer is A minus B. Most books, they'll tell you that this is like 0.69 something and that's 1 point something, and then you gotta figure it out, but that's okay. This is fine. Okay, let's do something a little tougher. 28. Natural log 27. Now, to do this one, you want to change 27 to 3 to the 3rd power. Why? There's two reasons. What are the two reasons? Well, first of all, they only tell you what natural log 2 and natural log 3 are. So you want to get either 2 and 3 here. And then, why do I want to have it as a power? Because what does the 3rd property say? If you have a number to the power, you can just take the power and put it in the front. So, if I take this power and put it in the front, what are you going to get? 3 natural log 3. But natural log 3 is B. That's B, so the answer is just 3B. Are we catching on? So either you're looking for something plus something, something minus something, or something. Or, you know, you have to be able to go from the left to the right, but you also have to be able to go right to the left too. Okay, let's do number 30. Number 30 looks scary. Natural log of the 4th root of 2/3. Now, the 4th root means what? What power does that mean? It means 2/3 to the what power? 1/4 power, right? Like square root means 1/2 power, right? Cube root means 1/3 power. Okay? And then, what happens when you have a number to a power? What can I do with this power? Put it in the front. And then now, what do I do with this one here? Natural log 2/3. Well, that's like this one, right? So when you have natural log of m over n, that's the same thing as natural log 2 minus natural log 3. A, but that's A and that's B. So your final answer will be 1/4 A minus B. So you have to manipulate it so that you just get natural log 2s and natural log 3s, so you can substitute A and B for it. Okay, and we have to go up to what number? 35. Okay, let's do 32 then. It says express each expression, write each as a sum or difference. See how each section each section, one of them goes from here to here. Then you practice that. Then the next section, you're going from here to here. So you're kind of sorting it out for you. But by the time you get to the test, hopefully, I'm not going to give you any hints, right? You're just going to be able to go both ways. Okay, so look, this is the argument right here. It's something over something. That means I want to use this one. So applying that property there, what is that equal to? Log base 3 of x minus log base 3 of 9. Yeah, but Mr. Park, I know what that number is. What does this mean? 3 to the what power equals 9? That's 2. So their final answer is log base 3 of x minus 2. Okay, one last one. How about 34? This one looks easy. Log base 7 of x to the 5th. Well, when you have something to a power, what can I do with the power? Put it in the front. Finished. So there you go. So you guys just have to practice, and then we're going to spend 2 nights on this so you get really good at it, okay? So these are it. Write it down, or if you look in your book, look at your book right here. You see where the problems are? Look right here. They have it all in one place. So you can look at it right there. That's exactly what I have written on the board. Okay, any last questions? Okay, let's go to the tennis courts. This is your chance now.
Yes.
Do I have to explain the rules? Nope. Okay. You know what? If you don't have class, and your next class is not in Weinberg, you should take your books with you.
What about E?